going to explain the objective of this video. Firstly, to understand the definition of differentiation. Secondly, to elaborate the maximum and minimum problem. Thirdly, to identify the step to solve the maximum and minimum problem. And lastly, to solve some of the maximum and minimum problem.
So next one is differentiation. Differentiation is a process of finding a derivative, which is the instantaneous rate of change of a function with respect to one of its variables. Differentiation in calculus can be used to calculate the function per unit change in the independent variable.
What is the maximum and minimum problems in differentiation? It is the process of finding maximum or minimum value is called optimization. And is also a practical example might maximize the profit in the company, minimize the cost, or find the least amount of material to make a particular object.
The steps for solving maximum and minimum problem. Firstly, draw an appropriate figure and label the quantities relevant to the problem. Secondly, find a formula for the quantity to be maximized or minimized. Then, identify the quantity to be maximized or minimized as a function at one variable. After that, find the values of x when dy over dx equal to 0. Next, find the second derivative and substitute x from the previous value step to differentiate between maximize or minimize. For determining the value of y, either maximize or minimize, substitute s into y.
Hello, my name is Nurshami Maatria binti Khair Suhairi and my metric number is 2020857884. So today I will teach you how to solve the question involving maximum and minimum in differentiation. So the question is, a rectangular plot of land is to be fenced using two kinds of fencing. Two opposite sides will use heavy-duty fencing at the cost of Rm6 ringgit per meters, while the remaining two sides will use standard fencing at the cost Rm4 ringgit per meter. If the total cost of fencing a rectangular plot is Rm1200, find the dimension of the rectangular plot of the greatest area. So, to solve this kind of question, first we need to draw the diagram so that we can clearly understand the question, because sometimes the diagram is not given to us and sometimes it is given. Then, we need to identify which side is x and y. Second step is you need to look carefully into the question and write the keywords given in the question. The third step is we need to make y as a subject, because later equation of y will be put into the formula of the area. So note here, y here is 6s and 4y, because the cost is Rn6 and Rn4 respectively for each side, and y here is 2, because the question mentioned is 2 sides. After we got the equation of y, then put it into the formula of an area, then solve and simplify it So the final equation will be like this. Next, we need to do first derivative for the final equation, and it will be like this. To find the critical point or the value of x, dA dx is equal to 0. Then solve it until we get the value of x. Next is to find second derivative. Why we need to find second derivative? Because we need to identify the final answer will be maximum or minimum point. So here we know that our point is maximum point. So here we can know our point is correct. It's because maximum point can be used to find the greatest area of the land. We already know the value of x, right? So in order to answer the question, which is to find the dimension of the land, we need to find the value of y. So all we need to do is just substitute the value of x, which is 50, into the first equation of y. Lastly, we can get the dimension of the land at the greatest area.
The problem statement. Mass Airlines requires that rectangular baggage carried on an airplane be such that the sum of dimension, length, width, and height is 135 cm. Find the dimension of baggage that will maximize the volume, given that the length of the baggage must be twice the width. Question 2. From the problem statement, we know that the length of baggage must twice the width, which is we can set variable for width as x and for length as 2x. Then the variable for height is y. We also know that the sum of dimension, which is length plus width plus height, is 135 cm. That's how we get 2x plus x plus y equal to 135 cm. From this equation, we will set y as a subject to make a function. Then find a suitable formula with this problem. I choose volume formula, which is length times width times height. So we substitute the value into the formula. Then we will get volume equal to x times 2x times y. And we substitute the value of y from the previous step. And we will get 3x. 3x times 135 minus 3x. And simplify to get 270x squared minus 6x cubed. Find the first derivative of function or dv over dx and get 540x minus 18x squared. Then the next step, we will find the value of x. We've set dv over dx equal to 0 and get the equation 540x minus 18x squared equal to 0. Then simplify this quadratic equation and get x equal to 0 and 30. And we will choose x equal to 30. To determine whether the value is maximized or minimized, we will find the second derivative of the function and substitute the value of x. So we will get this square b per dx square equal to 540 minus 36x and substitute the value of x, 30, and we will get 540 minus 36 times 30, and the final answer we will get negative 540. When we get the negative number, it determines the maximum. The dimension of the baggage with x equal to 30 cm, the length 2x equal to 2 times 30 and get 16 cm, and the height y equal to 135 minus 3x, and substitute the value of x, when we will get 45 cm.
So for solution to question 3, as stated in the question, the volume of the box is 15,000 centimeter cube and the length of the box is 3 times of its width. I name the width with x. So to find another unknown, we can use the volume formula. So volume is equal to L multiplied by X and multiplied by Y. So L here is length, X is width, and Y is its height. So volume 15,000 equal to 3X. I replace L with 3X multiplied by X and multiplied by Y. So we got 3X square multiplied by Y. So in order to make Y as the subject, so we put it here and we got 5,000 over x square. Okay, as the question wanted us to minimize the surface area, so we need the surface area formula. So surface area formula, I name it as A is equal to 2lx plus 2ly plus 2xy. So I replace L with 3x, L with 3x, and y with 5,000 over x square, and y here as 5,000 over x square. So multiply it and we got 6x square plus 3,000 over x plus 10,000 over x. We add it all and we got 6x square plus 14,000 over x. So after solving the surface area formula, we need to find the critical point, which is the first derivative. In this question, the first derivative is dA over dx. So we need to differentiate the surface area. So first, differentiate 6x square, we become 12x, and differentiate 14,000 over x become negative 14,000 over x square. Okay, for critical point, the derivative is equal to 0. So first we need to match the numerator first. 12x multiplied by x square, we got 12x cubed minus 14,000. So so the numerator we move it here and we got 0. So we solve it and x is 14.938. Okay, so the next step is finding the second derivative. It is to determine whether the critical point is maximum or minimum point. So second derivative is you differentiate the first derivative, which is 12x minus 14,000 over x square. So we differentiate 12x, we become 12, and differentiate 14,000 over x square become 80,000 over x cubed. So we replace x. Here. We got 36. So the 36 here means the critical point is minimum point. It is because when we got positive point, it means it is minimum point. And if we got negative number, it is a maximum point. Okay, so for dimension, width, which is S, x is 14.938 cm, and the length 3x, we multiply the x by 3, so 3 multiplied by 14.938, we got 44.814 cm. And for its height, which is y, we take it here from the volume formula. So y equal to 5,000 over 14.938 square. So we got 22.407 cm. Okay, so for the minimum for surface area, we can take the surface area formula that we got, which is 6x squared plus 14,000 over x. We just replace the x with 14.938, and we got 4,018.5977 cm square.
In a conclusion, application of apply maximum and minimum problem are widely used in real life. Many kinds of industry use this method to solve their problem, such as business platform to count their profit, either its maximum or minimum.